this is similar to the last problem where we used the heating curve, but here I'm just going through the transition. So freezing is going from a liquid to a gas, so this would be more from a cooling curve. But I'm specifically just looking at the transition where I'm going through the phase change, so I don't actually have to draw out the cooling curve for this one. So for this problem, I'm going to use the equation Q equals N, where N is number of moles, delta H of fusion, because fusion is freezing. So the delta H of fusion works both for freezing and melting, and the heat of vaporization, or the delta H of VAP, works for both melting and boiling and condensing. So first thing I have to do is convert 27.2 grams of water into moles. So I have 27.2 grams times 1 mole of water is 18.015 grams. How do I get that? I add 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. So I'm going to do 27.2 divided by 18.015, and I get 1.51 moles of water, and that's my N. And then to get the heat, all I have to do is multiply that 1.51 moles by the delta H of vaporization, which is given, which is 6.02. And I get 9.09 kilojoules. So this problem says released. So technically, the answer 9.09 kilojoules is correct because 9.09 kilojoules is released. If it just said how much energy is, or what is the delta H, or how much heat is involved, right? If it didn't use the word released, I would have to say it's negative 9.09 kilojoules because that negative means released. So technically, to put the negative here, given that it says released, is actually redundant. You don't need the negative.